Today we're going to focus on the concept of addition maps, which is one of the teaching strategies. It's good to use for lower level primary like kindergarten and year 1, and it gives students the opportunity to be able to see concrete materials being used. So today we're just going to focus on 2 plus 4. So you can easily make a addition map by yourself. Just these are clouds. You can make it look better if you want. So you grab 2 blocks or counters or anything and just pop it in one cloud. Then you would get 4 more and stick it in the other one and demonstrate this to the students. And then you'll put them all together because you're plussing, and then you'll put them into the big cloud, and then you'd ask the students to count how many are left in the big cloud. So you have 1, 2, 3, 4, 5, 6, and then the students can write their answer here, 6. Or you could do 3 plus 1. So you can have 1 in one cloud and 3 in another cloud, and then you bring it all together and you have your answer, which is 1, 2, 3, 4, and you write it in. A common misconception within students is not understanding the place value of the digit in an algorithm. So for example, you could have 19 plus 1. Some students may write it as 19 plus and put the 1 in the tens column and leave the ones column empty, and they would answer it as 9 because there's nothing there, and 1 plus 1 equals 2, so they would answer 29. To prevent this, you could use a hundreds chart with counters, MAB blocks, just anything to represent numbers. So today we have little coloured blocks. So I demonstrate to the students that you'd place 10 in the tens column. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 9 in the ones column to represent 19 as a whole. So 1, 2, 3, 4, 5, 6, 7, 8, 9. And then you'd be plussing 1 and you put that in the ones column. But then students will realize that they have 10 in the ones column, so that could be transferred into the tens column, which is now 20. And students can write that down. So that's wrong. Now we'll be focusing on a teaching strategy for subtraction, and I've chosen to focus on the subtraction mat as it can be reused from addition, which is useful to reuse resources. So in subtraction, you know one part, so say for instance 4 minus 3, one part, which is 4, which would go in the big section, and you want to take away 3, and then you can see what you are left with in the big cloud, which is 1. And then you could have 6 minus 1, so you move it back into the big one because that's the total. and then you minus 1 to a cloud, and you count how many are left. So you have 1, 2, 3, 4, 5, and then you'd write down 5. A common misconception with subtraction is trading within algorithms. So for example, you might have 34 minus 18. Students can see that 4, you can't minus 8 from 4, so they might say 8 minus 4, and then they would write that down as 4, and then they would say that 3 minus 1 equals 2 and have 24 as their answer. This is incorrect because 4 minus 8 you'd have to trade. So you could show students this through the use of a place value chart. This has been preset already. So as you can see, there's 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 3 rows of it. So 10 times 3, that's 30, and then you have your 4 ones to represent the total, which is 34. And you'd want to minus 18. So first you would begin with the ones, but as you can see, you can't minus 4, so you have to borrow 10 from the tens column to make this now 14. So as you can see, you would make this 20 and turn this into 14. And then you would subtract 8, so 1, 2, 3, 4, 5, 6, 7, 8. And now you're left with 1, 2, 3, 5, 6. So then students can write their answer down, 6. And then they can minus 10 from the tens column and be left with 10. And writing that down, you'd be left with your answer, which is 16. A teaching strategy for multiplication is use doubles, and this can be done with your 2, 4, and 8 times tables. Okay, so for an example, we have 2 times 4. So this is seen as repeated addition, so you can go 4 plus 4, because there's 2 lots, equals 8. So here you have your double, and 8 is your answer, so you can record that there. And then you can have 4 times 4, so that'll be 4 plus 4 plus 4 plus 4. Here you have 2 lots of doubles, so it goes double, double. And 4 plus 4 plus 4 plus 4 equals 16. And you can record that here, up the top. And then moving on from that, we have 4 times 6. So you'd write 4 plus 4 plus 4 plus 4 plus 4 plus 4. Here you have 3 lots of doubles, so double, 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 which then becomes 24. As you have the answer there, and then you can write 24 up the top. A common misconception with multiplication is forgetting to add the carrying digit when trading is involved. Okay, for example, you can have 63 times 4. 4 times 3 is 12, carry over the tens. Then you have 4 times 6, which is 24. Here, students forget about the tens sitting above the 6 and would just write 24. In the next demonstration, I'll show how the carrying can be done. So you have 4 times 3, which is 12, carry the 1, and then you have 4 times 6, which is 24, plus 10 because the 1 is within the tens units, so that becomes 25, which gives you the answer of 252. I would demonstrate this to students with the use of concrete materials such as MAB blocks, and I'd let them use the concrete materials until they feel comfortable to do so by themselves. Today I'll be demonstrating the teaching strategy of long division. So we have 764 divided by 4. Okay, so you'd put 4 goes into 7 how many times? It goes in once with 3 remainders, so you can write that underneath. And then you bring down the 6, which now becomes 36. And then you go 4 into 36 goes 9 times with no remainders. And then you can have 4 into 4, which is 1, leaving you with the answer of 191. Today we'll be focusing on dividing by 0 and how it being a misconception within students, and it's difficult for students to grasp as 0 is not defined. So first I would begin by showing the relationship between division and multiplication. So 6 divided by 3 equals 2, 6 divided by 2 equals 3, and 6 divided by 1 equals 1. And then I'd do the multiplication, which is 3 times 2 equals 6, 2 times 3 equals 6, and 1 times 6 equals 6. And then students will be able to see the inverse relationship between the two and how they work together. Then I would move on to show 6 times 0, which they would know is 0 as they would learn multiplication prior to division. And then I'd say, so what do you think 6 divided by 0 is? And they would say 0. If students still don't understand, I would give live demonstration. So I'd get 6 students up, 2, 3, 4, 5, 6, and if I said that I had 0 balls to hand out to 6 students, I would pretend to hand out balls, which I wouldn't have, and then I'd ask the student, so how many balls do you have? And then they would say 0.